Hello, AP Chemistry, and welcome to a quick overview of your guys' EPs since everybody turned it in on the actual due date, which happens to be literally one day before your test. But I did want to highlight a couple of things that I noticed. I haven't graded all of them, so it is possible that what I'm going to say only applies to the half of the packets that I looked at, but nonetheless, I feel like these are useful things to point out. So first of all, here, 1D, right? Or D1, well, 1D sub 1, right? Indicate whether switching from 1 molar to 2 molar reactants changes the value of Q, right? A lot of you guys went with, oh, mass doesn't change, therefore Q doesn't change, right? And yes, that's true, right? Given this, right, as an equation, right, Q equals MC delta T, yeah, absolutely, right? If mass does not change, Q does not change. But, right, while the mass of the respective solutions might not change appreciably, right, you can't throw away all the chemistry that you know, right? The mass doesn't change, but we have literally doubled the number of particles in the solution, yes? We have doubled the number of particles in the solution, which means that the delta T will change, right? Because if we think about what's happening, heat is being released every time an HCl and an NaOH react to produce sodium chloride and water, right? Which means every time that reaction occurs, a tiny bit of heat is released into the surroundings, right? If we double the number of those reactions, we must affect our delta T, right? So actually my answer could be better. I just talked about how if we increase the number of moles, right, the mass must go up, right? But really, it would also be a great answer to say, right, that if I double the number of particles in the solution, I double the number of reactions. So even though mass may not change appreciably, right, delta T will definitely go up to reflect the increased number of reactions in the solution, right? Which then brings us to D2, right, which talks about delta H of the reaction, right? And note here is where units are important, right? We're not talking about Q, we're talking about delta H of the reaction. Heat of the reaction does not change because while we've increased our Q, we've also increased our moles, right? Proportionally, therefore, no net change for heat of the reaction, right? Heat changes, heat of reaction, no change. All right, which also goes back to what we were talking about earlier, right? So this whole question is designed as a calorimetry question, right? So when we're asked to speculate about heat, right, or enthalpy, we would do it by using the data provided because there is data, right? We have information to use, right? We have densities and assumptions that we can make. So that's what we would use, right? Whereas in other questions, right, so for example, here we're asked to compare entropies and we're just given some conditions, right? So that's what we're going to have to use. Trying to find a point of reference question. Here, right, we have heats of formation, delta G of formation, and standard molar entropies, right? So here when we're asked to talk about G and S, right, clearly we're going to use the data provided, right? We're going to use what's in front of us, okay? Always. All right, other ones to talk about. Number 3. So I did want to talk about here, I can't emphasize enough, I've mentioned it before, and I'm going to say it again, right, that if we are given things to compare, right, we must address all of those things, right? So it's not enough to just say this one, right? We have to talk about HE at 1 atmosphere versus HE at 0.05 atmospheres, right? Same temperature, what's the significance of that? What is the significance of 0.05 atmospheres versus 1 atmosphere, right? How does that tie into what entropy is, right? What's the difference between the microstate pictures for both of those samples, right? For number 3, a lot of you guys just went, oh, more complex. What does more complex mean, right? More complex means more bonded atoms. More bonds means more potential vibration and rotation about those bonds versus the 2 bonds present in H2O, right? So the thoroughness of your guys' answers, from what I've read so far, overall lackluster, okay? Could be I just haven't gotten to the stellar ones, but overall, not so good. And they will not earn full credit tomorrow. Okay, next one I wanted to talk about is 6B. All right, this one, reading this is just terrible, okay? So let's read, right? So it says we have some ammonium chloride is added at 25 degrees, some dissolves, right? That tells you, right, that gives you negative delta G. Temperature of the system decreases, right? That gives you your delta H, yes? The wording there is not stellar, right? It should say that the temperature of the measured temperature decreases, right? In that this process is endo, right? And then entropy, you're like, oh, well, there is no basis for entropy, right? Because I think a lot of you got this delta G part right. It happens. Delta G is thermodynamically favorable, right? A lot of you guys hit on delta H as being positive based on temperature. Some of you guys tried to go with a products and reactants point of view here, right? Note that that doesn't work, right? To talk about products versus reactants, okay? Every reaction is, oh my gosh, that's horrible. Oh, geez, what is that? Okay, yeah, okay, whatever. I'll figure that out later. But everything is products going to reactants, right? Every single reaction, right? Which means that here we are always breaking bonds, always. Here we are always making bonds, right? That is always true for every reaction, whether it's endothermic or exothermic. A lot of you guys, to try to make your justifications, are talking about, oh, we make bonds, so it must be exothermic. No, every reaction makes bonds. That doesn't even make sense, right? So what we have to think about is the balance of all of that, right? So here, this is always going to be, right, energy in. This is always going to be energy out, right? E in, E out. And so for an overall reaction, it's always going to be the balance of that whole thing determines whether or not a process is endothermic or exothermic, yes? Right? You can't just decide because bonds are broken or bonds are made. No, that applies to every single process, right? So you have to have something else to go on, right? So either you have to have heats of formation, you have to have, and then you can do this sum of the products minus the sum of the reactants, or you could have a series of reactions, which you could use Hess's law to apply, right? Flip as needed, scale as needed to come up with the process you're looking for. Alternatively, we could have some information about bond energies, right, which we talked about a little bit, or, right, we could have some calorimetry data, right, or something about temperature change. But you cannot speculate based on bonds broken and bonds formed, right? We are not in a place where that is an option, okay? And then that brings us to the final part, right, which talks about how to predict the entropy, right? Some of you guys just went with, ooh, it went from solid to aqueous, must be an increase in entropy. Well, actually, no, right? That's exactly what we talked about during the demo, right? Wherein the whatever was solid, yes, entropy of that increases, okay? Entropy of the water decreases, right? Here again, we have conflicting things, right? And we have to figure out what the net change is, right? So just like we talked about here, entropy of ammonium chloride increases, entropy of water decreases. The net entropy of reaction is going to be based on the net change. The only thing we have to go off of here is our two pieces of information. If I know that delta G is equal to delta H minus T delta S, and I've already defined delta G as thermodynamically favorable, I've defined delta H as being, ooh, not so favorable. That means S must be what? Right, it must be favorable, or G could not be favorable. Yes? Does that make sense? If H is unfavorable, G is favorable, then S must be favorable. Yes? Does that make sense? Right? That's how we come to a conclusion about the sign of delta S. Yes? Right? We have to work with what we've got. Okay? So, make sure you pay attention to that. Very, very important. All right. Next up, I did want to talk about number 10 really quickly. By the way, your guys' lack of attention to to your moles and things was disheartening. Here, number 10 is the same thing, where a lot of you guys just didn't really answer the question very well, right? So here, again, if the reaction proceeds spontaneously to the right, so it goes that way, right, which means delta G is negative, right, predict the sign of the enthalpy. So this is like that other one, backwards, right, but backwards. Here, we predicted delta S already, right? We have gas to a solid, so we go from 2 moles of gas to no moles of gas, which means negative delta S, right? And I know it proceeds spontaneously, which means negative delta G, right? So then, what does that mean, right? Is there a sign that enthalpy must be? Ding, 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 right. It must be negative, right? Because again, here we have an unfavorable entropy, but a favorable delta G, which means that this must be the changing factor, right? This must be the turning point, okay? In that if both H and S are unfavorable, G is always unfavorable, right? If H and S are both what did I say? Unfavorable. Anyway, if H and S are both unfavorable, G is always unfavorable. If H and S are both favorable, G is always favorable, right? And and it can be one or the other also, right? But we have to make sure we reason through that. Okay. Okay. So yeah, anyway, pay attention. There were lots of terrible answers there. C, also lots of terrible answers. So the question says, the direction in which the reaction spontaneously proceeds changes as the temperature is increased. Explain. A lot of you guys literally rewrote that question and called it an explanation, which it's not. You guys talked about, oh, at low temperature, it's, one thing, and then as we increase the temperature, it's another thing. No, that's what the question said. You need to provide a reason why, right? Now here, it's true that the B and C are so closely linked that if you didn't understand enough to put a right answer for B, odds are you weren't gonna get C, right? But C is about why this is the case, right? And here, this goes back to if H is negative and S is negative, right? As that temperature becomes large enough, right? Then eventually that T delta S term, once that becomes bigger than the delta H term, that flips the sign of delta G, right? That's what the explanation is, right? Going back to that equation. Again, most of your answers, not very good. All right. I think that's it. Thanks for listening. Study, review, and I will see you guys tomorrow. But get a good night's sleep, more important. All right. Don't forget, I won't be there for ALAP. So, but I will be back in time for your test. All right, be good. See you soon. Bye.